A toy rocket is launched twice in the air from level ground and returns to level ground. The rocket is first launched with an initial speed of v at an angle of 45 degrees above the horizontal. It's launched a second time with the same initial speed but a different launch angle increased to 60 degrees. Describe how both the total horizontal distance the rocket travels, so the horizontal distance the rocket travels, and the time in the air are affected by the increase in launch angle. So in the first case, here's our level ground. We're launching at 45 degrees, so it has this kind of trajectory. Let me try that again. So initially, it's launched with this 45 degree trajectory. And it's going to take on this kind of a path. And then they do it again, and I'll draw it over here. They give it a little bigger launch angle. Now all of a sudden it's like 60 degrees. And it goes higher, but the question is, does it go as far? So these are the two situations. So this is the first one they do, and this is the second one they do. And they want to know about total horizontal distance traveled and time in the air. So how can we break this down? Well, we have that initial velocity v being the same in both cases. So the initial velocity here is v, initial velocity here is v. It's just that they're in different directions. So we can decompose that into the vertical and horizontal components. Let's work on time in the air first. So first we're going to focus on the vertical component of that initial velocity. So the vertical component, vy, is going to be equal to the initial velocity v times the sine of the angle. So we'll do it for the 45 and we'll do it for the 60. So it's going to be sine 45, and then the other vy is going to be v sine 60. So in this case, v sine 45, what is the sine of 45 degrees? That's going to be root 2, right? Or is it 1 over root 2? Let's draw the triangle. So if this is 45 degrees and this is 1, then the vertical component is going to be 1 over root 2, right? So this is v over root 2. And then for sine 60, what is the sine of 60? Let's do that one as well. If this is 60 degrees and this is a right angle and this is 1, then the sine will be root 3 over 2. So here vy equals why don't we say root 3 over 2 times v. Okay, so that's vy for 60 degrees, and that's vy for 45 degrees. And I could prove this, but I think you'll believe me if I say the time is directly related to the velocity. The faster that vertical component of the initial velocity going upward is, the longer it's going to be in the air. And that's a linear relationship. And again, we could prove that, but if you'll take my word for a moment, we could say the ratio of the time in the air for the 60, and also we suspect the 60 is going to spend more time in the air, right? Because it's being shot straight up, whereas 45, that vertical component is going to be smaller. So the time in the air for the 60 compared to the time in the air for the 45 is going to be root 3 over 2v. That's the velocity, the initial velocity of the 60 degree launch angle. And that's being divided by 1 over root 2v. So the v's cancel, and all you're left with is these fractions. So you have root 3 times root 2 is going to be root 6 over 2, and that turns out to be equal to 1.22 something. So you could say that the hang time of the 60 degree launch angle rocket is, or say 60 degree launch is in air 22% longer than the 45 degree angle. And the most important thing here is for you to just recognize the qualitative. I think on the test they're just looking for you to say the 60 degree launch angle is in the air longer than the 45 degree launch angle. and that's probably good enough, but here we actually calculated that it's in the air for 22% longer. So now how could we calculate which one goes farther? Well, how would we calculate the horizontal distance? The horizontal distance is equal to the horizontal velocity, Vx, times the time that it's in the air. So the horizontal distance depends on the time. So we have to understand how much longer this one's in the air, because even though it doesn't look like the second case is going to go as far, because the horizontal component of its velocity isn't as great as the 45-degree angle, but it's in the air longer. So even though it has a smaller Vx, it has a larger t. So maybe it could have a d that's just as big or even bigger. The only way we can calculate that, I think, is by knowing how much longer this one is in the air than the other. And we know that exactly, so we can work that out. So the distance for the 45 would be expressed as, alright, distance for the 45-degree launch angle, it's Vx, which is going to be V cosine 45, times its time in the air, which we don't know its time in the air, but we'll just assume it's 1. And then the other one we'll assume it's 1.22. So we don't know the actual explicit times in the air, but we know them relative to one another. Alright, so this will give us initial velocity times cos 45 is 1 over root 2, so this will give us V over root 2. And then the distance for the 60-degree launch angle will be V cos 60 times 1.22, because we're accounting for that larger time in the air. It's 22% more. So that's going to be, what's the cosine of 60? It's this guy, right? So it's 1/2. So that's going to be V over 2 times 1.22. So I'll say 1.22 over 2 times V. And now the ratio of these two, we suspect that the 45 is going to go farther, right? That's our gut feeling. So let's make that the numerator. So d45 divided by d60 is V over root 2 divided by 1.22 over 2 times V. So the V's cancel, and we end up with 2 divided by 1.22 times root 2. And if you'll take my word for it on the calculator, I got this ratio to be 1.16, which is to say that our gut reaction was right. The 45-degree launch angle does send it further. The total horizontal distance is further by 16%. So 45-degree launch is 16% farther. And again, qualitative answers are probably okay. All you really have to say to get full credit for this question, is not so much in terms of these percentages. It's just the 60-degree launch angle has more hang time, spends more time in the air, and the 45-degree launch angle has a greater horizontal distance covered. And that's all.